Hello, and today's learning target is I can write and graph linear equations from word problems. So this video is very similar to the last video with word problems. However, we are not given the equation from our word problem. We have to create the equation based on what we read, create a t-chart or table, and then graph that data that we found in our t-chart. So let's take a look at the first example. A cell phone plan costs $15 per month plus $3 per gigabyte of data used for the month. Let Y represent the cost per month. Let X represent the number of gigabytes used. Write an equation, make a t-chart or a table, and graph. So the first thing we need to do is we need to write an equation for this data. I'm going to zoom in here. For the word problem data that we're given. So we need to write a correlation of $3 per gigabyte of data used, but then in just a $15 charge per month to even have the cell phone. So to write this, this is going to be Y equals 3 times however many gigabytes of data are used, plus the flat fee of $15 per month just to have that cell phone plan. So now that we have our equation, we need to create a t-chart or a table and then graph. So I'm going to plug in the values for x and find my output y. So if I plugged in 0, y equals 3 times 0 plus 15. Well, 3 times 0 is 0 plus 15 is 15. Now if I plug in 1, y equals 3 times 1 plus 15. 3 times 1 is 3, plus 15 is 18. If I plug in 2, y equals 3 times 2 plus 15. 3 times 2 is 6, plus 15 is 21. If I plug in 3, y equals 3 times 3 plus 15. 3 times 3 is 9, plus 15 is 24. All right, and the last one we'll plug in will be 4. Change colors here. So y equals 3 times 4 plus 15. 3 times 4 is 12, plus 15 is 27. All right, let's go ahead and look at our graph, and let's make our graph. Okay, so first we need to label our axes, the x-axis and the y-axis. And on the x-axis is number of gigabytes that are used, right? That can change. That's what we could have plugged in for x, any number of gigabytes that were used. So number of gigabytes used. And then the y-axis would be the output, the y values of cost, or the dependent variable, what depends on the number of gigabytes used, cost per month. Okay, and that again is in dollars. So if I label my axes, I'll start with 0, and I'll go up by 2's. And then on the y-axis, I'll count by 10's, but each line will represent 5. So count up by 10's. And then I'm going to look at my ordered pairs, and I'll graph my ordered pairs. So 0, 15. Oops. Okay. 0, 15 would be right here. Okay. Then I need to graph 1, 18. So a little bit above it. 221. Again, these should form a straight line. 324, excuse me. And again, I'm trying to draw as accurate as I can with this stylus. 427. And that's all we have on our table of values. So I'll make a straight line, as straight as I can make it. Let's try that one more time. And that would be my graph for this problem. So again, what we did is we wrote an equation from this word problem, created a t-chart or a table with ordered pairs that we filled in, or found out and then filled in, and then our graph. And we labeled our axes, we labeled by an appropriate unit amount, and then we made our straight line of our graph. Let's take a look at the next example. Jacob's business of selling hockey sticks had an initial investment of $300, but he makes a profit of $25 for each hockey stick he sells. Let Y be the net revenue of Jacob's company, and let X be the number of hockey sticks Jacob sells. Write an equation, make a T-chart, and graph. Okay, so let's start here by first making or writing our equation. So to write this equation, we know that the number of hockey sticks Jacob sells, he earns $25 for each of those. So that is what could change, or that is what we're going to have as our variable. So we're going to have Y equals, and again, Y is our net revenue, so how much he will make at the end of his of selling the hockey sticks, and $25 per hockey stick. So 25 times X, where X is the number of hockey sticks he sells, and then he had an initial investment of $300. So he first paid $300 to even, have this business. So that's why it's minus $300. And that will affect our graph, and why our graph has part of our y-axis that will actually have some negative values too to this. But let's first fill out our table. So I'm going to zoom in here. There we go. So if I plug in 0, I get Y equals 25 times 0 minus 300. So 25 times 0 is 0, minus 300 is negative 300. And that makes sense. If he doesn't sell any hockey sticks, he's out $300, and that's what he initially paid to start his business. Excuse me. So now if I plug in 2, 25 times 2 is 50. 50 minus 300 is negative 250. Okay, if I plug in 4, Y equals 25 times 4 minus 300. 25 times 4 is 100. 100 minus 300 is negative 200. If I plug in 6, Y equals 25 times 6 minus 300. 25 times 6 is 150. Minus 300 is negative 150. And then lastly, I'll plug in 8. So Y equals 25 times 8 minus 300. So 25 times 8 is 200, minus 300 is negative 100. So you can see our table increases by 50 each time we increase in the values of number of hockey sticks sold. So if I want to make my graph now, again, see how I have a negative value for my y values, and that's because we can have a negative amount if Jacob doesn't sell any hockey sticks. So I am going to go ahead and label, and my x-axis is number of hockey sticks sold. So I'll just say number of hockey sticks sold. And the y value is this net amount. So I'll do net amount in dollars. And so we'll start at 0, and we'll increase each increment. We'll say that's $100, $200, $300, $400, $500, and we can stop there. And then here we'll go negative $100, negative $200, negative $300, negative $400, negative $500. And we'll count by 2s, 2, 4, 6, 8, 10. And we'll go ahead and we'll graph our ordered pairs. So 0, negative 300 would be right there. So if he doesn't sell any hockey sticks, he's negative $300. If he sells one hockey stick, he's negative 250. Or 2 hockey sticks, excuse me. If he sells 4, negative 200. Again, this should be a straight line. If he sells 6, negative 150. And 8, negative 100. So connect those, make our line, and that's our graph. Now let's answer a few questions about this problem. How many hockey sticks does Jacob need to sell to break even to cancel out the $300 investment? That means he would break even. Okay, so I'm going to zoom back in here. So to break even, he would need to, obviously get the $300 back. So for him paying $0, that's what he would net, right? So we want to, with our equation, y equals 25x minus 300, we want to see, when he would break even or not have to pay any money. So we'll put in 0 equals 25x minus 300, and let's solve for x. So if this was my equation, I would add 300. I'm going to run out of room, so I'll go right over here. So 300 equals 25x divided by 25, and 300 divided by 25 is 12. So he would need to sell 12 hockey sticks in order to break even or get his $300 back. Okay, let's look at the last question. How much would Jacob's hockey shop make after selling 20 hockey sticks? So after selling 20 hockey sticks, we want to figure out that amount. We'll plug in 20 for x because that's the variable that represents how many hockey sticks are sold. So y equals 500 minus 300. So y equals 200. So you would make $200 if you sold 20 hockey sticks. Thanks for listening. Have a great day. Bye-bye.